Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back, grade 7. Today, inshallah, we have a new lesson. It's triangle congruency SSS and SAS cases. Firstly, we will start with warm up. Name the angle formed by ray AB and ray AC. The common letter here is A, so the angle will be angle A. Or we can say that it's angle BAC or angle CAB. The second question, name the three sides of triangle ABC. Firstly, it's AB, then BC, then AC. Question number 3, triangle QRS is congruent to triangle LMN. Name all pairs of congruent corresponding parts. The three sides will be congruent and the three angles also will be congruent. We will start by the sides. QR is congruent to LM and RS is congruent to MN and QS is congruent to LM. The angles, angle Q is congruent to angle L, angle R is congruent to angle M, angle S is congruent to angle N. Okay? In the end of our lesson, we must apply SSS and SAS to construct triangles and solve problems. We said before that S is abbreviation for the word side and A is the abbreviation for the word angle. Number 2, prove triangles congruent by using SSS and SAS. Our new vocab, triangle rigidity and included angle. In lesson 4.3, you proved triangles congruent by showing that all 6 pairs of corresponding parts were congruent. The property of triangle rigidity gives you a shortcut for proving two triangles congruent. It states that if the side lengths of a triangle are given, the triangle can have only one shape. For example, you only need to know that two triangles have 3 pairs of congruent corresponding sides. This can be expressed as the following postulates. The postulate is if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. The hypothesis here, triangle ABC, and we have another triangle FDE. AB is congruent to FE, and BC is congruent to DE, and AC is congruent to FE. So the conclusion will be triangle ABC congruent to triangle FDE. Remember, adjacent triangles share a side, so you can apply the reflexive property to get a pair of congruent parts. Example 1. Use SSS to explain why triangle ABC is congruent to triangle DBC. Firstly, it's given that BA is congruent to BD. Also, AC is congruent to DC. And BC and CB are congruent. Why? Because the reflexive property of congruency. So the two triangles are congruent by SSS. Again, it's given that AC is congruent to DC and that AB is congruent to DB. By the reflexive property of congruency, BC is congruent to BC. Therefore, triangle ABC is congruent to triangle DBC by SSS. Check out example 1. Use SSS to explain why triangle ABC congruent to triangle CDA. Firstly, it's given that AB is congruent to CD and BC is congruent to DA. By the reflexive property of congruency, AC is congruent to CA. So triangle ABC is congruent to triangle CDA by SSS. The included angle. What we mean by the included angle? The included angle is an angle formed by two adjacent sides of a polygon, like angle B. Angle B is included angle between sides AB and BC. If we are talking about angle A, it's included angle because it's between sides BA and CA. And if we are talking about angle C, it's included angle because it's between the sides AC and BC. Okay, so the included angle, it's an angle between two sides. It can also be shown that only two pairs of congruent corresponding sides are needed to prove the congruency of two triangles if the included angles are also congruent. This is the second case, it's SAS. And we said that S refers to sides and A refers to angle. So now we are talking about the second case. Postulate 442. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. The hypothesis here, AB, is congruent to EF, and AC is congruent to ED, and the included angle A is congruent to angle E, then triangle ABC is congruent to triangle EFD. The letters SAS are written in that order because the congruent angles must be between pairs of congruent corresponding sides. Example 2, engineering applications. The diagram shows a part of the support structure for a tower. Use SAS to explain why triangle XYZ congruent to triangle VWZ. Firstly, we will start by the sides XZ is congruent to VZ, and that YZ is congruent to WZ. By the vertical angles theorem, angle XZY congruent to angle VZW because they are vertically opposite angles. And we said that the vertically opposite angles are congruent. Therefore, triangle XYZ congruent to triangle VWZ by SAS. Okay, check out example 2. Use SAS to explain why triangle ABC is congruent to triangle DBC. It's given AB congruent to DB. And by the reflexive property, BC is congruent to BC. And angle ABC is congruent to angle DBC. So the two triangles are congruent. Triangle ABC is congruent to triangle DBC. It's given that BA congruent to BD and angle ABC is congruent to angle DBC. By the reflexive property of congruency, BC is congruent to BC, so that triangle ABC is congruent to triangle DBC by SAS. The SAS postulate guarantees that if you are given the length of two sides and the measure of the included angle, you can construct one and only one triangle. Example 3, verifying triangles congruency. Show that the triangles are congruent for the given value of the variable. Triangle MNO congruent to triangle BQR when x equal 5. Firstly, we want to substitute with the value of x in triangle QRB to find the length of the sides. We will start by the side BQ. BQ is x plus 2 and the value of x is 5. So BQ equal 5 plus 2 equals 7. The next step QR. QR is x, so x equal 5. Then RB. RB is 3x minus 9. Then we will substitute with the value of x. The value of x here is 5. So it will be 15 minus 9 equals 6. Then we will compare the two triangles to prove that they are congruent. BQ is congruent to MN. QR is congruent to NO. BR is congruent to MO. So triangle MNO congruent to triangle BQR by SSS. Show that the triangles are congruent for the given value of the variable. Triangle STU congruent to triangle VWX when y equal 4. What will we do? We have a triangle SUT. We want to substitute with the value of y in the two sides and in the angle to prove that the two triangles are congruent. ST is 2y plus 3. Then we'll substitute with the value of y. The value of y here is 4, so it will be 11. So ST equal 11. TU equal y plus 3. We will substitute with the value of y, and the value of y here is 4, so it will be 4 plus 3 equals 7. Measure angle T equal 20y plus 12. 20y plus 12, we will substitute with the value of y. The value of y here is 4, so 20 times 4 equal 80, and 80 plus 12 equal 92. The next step, we will compare the two triangles to prove that they are congruent. ST is congruent to VW, and TU is congruent to WX, and angle T is congruent to angle W, so triangle STU congruent to triangle VWX by SAS. Check out example 3, show that triangle ADB congruent to triangle CDB and T equal 4. Here we will substitute with the value of T to find the length of DA and DC and the measure of angle BDC. Firstly, we will start by DA. We will substitute with the value of T equal 4, so it will be 3 times 4 equal 12 plus 1 equal 30. Then DC equal 40, 40 minus 3. We will substitute with the value of T, so it will be 13. Measure angle D, it's 2T bar 2. Then we will substitute with the value of T bar 2. It's 4 bar 2 equal 16. Then 2 times 16 equal 32. The next step, we will compare the two triangles to prove that they are congruent. Angle ADB is congruent to angle CDB. This is definition of congruency. And DB is congruent to DB. This is reflexive property of congruency. Then the triangle ADB is congruent to triangle CDB by SAS. Proving triangles congruent. Given BC parallel to AD and BC congruent to AD, then prove that triangle ABD congruent to triangle CDB. Here we will make table, then write the statements, then the reasons. The first statement, BC is parallel to AD. BC is parallel to AD. This is given. What will we get from the parallel lines? Angle CBD is congruent to angle ABD. This is alternate interior angles theorem. BC is congruent to AD, and this is given. Then BD is congruent to BD, and this is reflexive property of congruency. Then the triangle ABD is congruent to triangle CDB, and this is SAS steps 3 to 4. Checked out example 4. Given QB bisects angle RQS and QR is congruent to QS, prove that triangle RQP is congruent to triangle SQP. The first statement, QR is congruent to QS, this is given. QB bisects angle RQS, also this is given. Angle RQB is congruent to angle SQB. This is definition of bisector. We will get that angle RQB is congruent to angle SQB. And QB is congruent to QB. This is reflexive property of congruency. Then triangle RPQ or RQB is congruent to triangle SQB. This is SAS steps 1, 3, 4. Okay. In the end of our lesson, I hope that you understand it. And if you have any questions, send it to me. I'm waiting for your questions. Thank you.